Hello and welcome to This Explainer. I'm incredibly excited you're here today because we're mapping out a highly structured professional HVAC system design course. Listen, this isn't just theory. This pathway is purposely designed to make you job ready in a massive, rapidly growing global industry. We're going to break down exactly how you transition from an absolute novice to a highly employable HVAC professional who is fully capable of designing the thermal environments of tomorrow. Here's a quick look at our curriculum map. We'll be hitting 5 major stepping stones: prerequisites and standards, fundamentals and refrigeration, psychrometry and load, systems and equipment, and finally, design and drafting. But before we can get to building the future, we really have to ask a foundational question. What knowledge is actually required to step into this field? Because, the indoor environments we live and work in don't just happen by accident. They're engineered. So what does it really take to get a job designing the air we breathe? Let's kick things off with Section 1, Prerequisites and Standards, basically building the foundation for a professional career. Now, because this is a serious career-focused course, we can't just dive headfirst into the advanced engineering modules. You absolutely need a baseline. You've got to be comfortable with the basic physical sciences. We're talking the principles of thermodynamics, concepts of work, energy, and power, and the fundamentals of heat transfer. These are your non-negotiable prerequisites. But once you've got these down, you are completely ready to learn the global languages of the industry. So let's talk about the professional framework you'll be operating in. You're going to see the acronym ASHRAE literally all the time in your career. They are the international society that sets the global building energy standards. Mastering ASHRAE standards means you speak the universal language of building efficiency. Bottom line, if you want to be employable worldwide, you design to ASHRAE standards. Similarly, understanding ISRAE, the Indian counterpart, opens up some incredible avenues. Being familiar with ISRAE connects you to vital networking opportunities, technical groups, and key educational resources. For your long-term career growth, aligning yourself with these professional societies is an absolute game changer. And you absolutely must know SMACNA. When you're out there on the job, SMACNA essentially writes the literal rulebook for safe and effective sheet metal and duct design. You'll be using their standards constantly to ensure every single piece of ductwork you design is totally up to code. Moving right along to Section 2, Fundamentals and Refrigeration. This covers modules 1 and 2, focusing on the core physics of HVAC. In our first modules, you're going to master the specific modes of heat transfer. It's kind of like a giant puzzle. You'll learn to calculate and compare sensible heat, which, simply changes the temperature of the air, against latent heat, which deals with moisture and the change of state. Understanding the delicate balance between these two is the exact skill required to ensure perfect indoor thermal comfort. Right at the core of the system, there are 2 main refrigeration cycles you'll learn to implement, depending on a building's energy availability. You've got the vapor compression cycle, or VCR, which relies on mechanical compressors, and the vapor absorption cycle, VAR, which utilizes heat sources. Knowing exactly when to specify which cycle is a high-level engineering decision, and you will be trained to make it. You'll also dive deep into the nuts and bolts that make these cycles actually work. Mastering the function of compressors, condensers, expansion valves, and evaporators, along with understanding modern, eco-friendly refrigerants and brines, makes you immediately valuable to global manufacturers and design firms. You aren't just learning what they are, you're learning how to properly select them for a job. Next up is Section 3, Psychrometry and Load. In Module 3, we get into calculating exact building needs. Transitioning from how the machines work to calculating exactly what a specific building needs, you'll be trained on the exact step-by-step sequence of load estimation. First, you learn to properly survey the building and the physical space. Second, you perform manual heat loss and cooling load calculations so you really understand the raw math. And third, and this is a huge one for your resume, you'll learn to run peak load simulations using the industry standard Hourly Analysis Program, or HAP software. This is exactly what you'll be doing day-to-day on the job. All right, Section 4, Systems and Equipment. This is Module 4, where we focus on selecting the right tools for the job. Once you know the building's load, you have to sort through a massive, complex list of technical systems to pick the physical equipment. You'll learn how to categorize the whole shebang. We're talking everything from direct expansion window units and package systems to advanced variable refrigerant flow, or VRF systems. You'll even go all the way up to massive hydronic chill water systems utilizing air handling units and fan coil units, along with all the auxiliary pumps that keep them running. So why does this matter so much? Well, knowing how to properly select an air handling unit or a water-cooled chiller directly connects your skills to the massive products being built and sold by absolute global heavyweights like Trane, Carrier, and LG. When you truly understand their equipment, you become the ideal candidate for the engineering firms installing these systems all over the world. Finally, we hit Section 5, Design and Drafting. Module 5 is all about blueprints and air distribution. This right here is the ultimate hard skill for landing a job, putting the air exactly where it needs to go. You'll apply those SMACNA standards we talked about earlier to properly size ducts using methods like equal friction and velocity reduction. You'll select the right diffusers and grills, calculate pipe sizes and valves, and even design specific fresh air and exhaust ventilation requirements for super complex spaces, like commercial kitchens and underground parking lots. This is the absolute daily bread and butter of an HVAC design engineer. And your educational pathway culminates right here with mastering AutoCAD. You're going to learn how to prepare professional floor drawings, create extremely precise duct and piping layouts, and generate detailed section drawings. Being able to take a building's load calculation and translate it into a fully compliant, executable AutoCAD blueprint, that is a highly sought-after, very well-paid resume skill for sure. As you finish this course and gear up to step out into the job market, I want you to keep this final thought in mind. The industry is actively searching for trained professionals who understand everything from fundamental thermodynamics all the way to AutoCAD drafting. The buildings of tomorrow are waiting. Will you be the one to design their breath? Thanks so much for joining me on this explainer, and I honestly can't wait to see what you build.